Hey folks, welcome to another episode of ASP.NET Core from Zero to Overkill. In this episode, we'll take a look at segregating our domain logic, which is normally on services, to specific classes regarding each use case with Mediator. So, in the previous episode, we took a look at onion, hexagonal, and all of that kinds of architectures. And although not really tied together, but I mentioned that one of the things that most annoys me in the traditional way of developing these applications is when we let the services get too big and do too much. So in this episode, we'll take a look at segregating that logic. So I'll start by trying to explain the problem. Then we'll describe how I feel this use case segregation can help us, and finally we'll take a look at the implementation we're doing in this application using the Mediator NuGet package. The usual plugs: if the videos are being useful, considering dropping a like, sharing them, and leaving feedback. Feedback is always the most important, but the other ones are also great that help the channel grow. And just a reminder that all the episodes have an accompanying blog post in my blog. And if you want to ask some questions and don't like the YouTube comments and stuff like that, feel free to drop me a line on Twitter. And otherwise, there are other contacts available in the blog or in my personal website. So, without further ado, let's get started. So, let's start by taking a look at what we had implemented previously. So, before we used this traditional layered architecture, and in good old fashion, we had some business layer. The name isn't relevant, but here is where we would put a lot of services because it's the usual way to do stuff. So I created these here, services, and created an iGroup service and put all the operations related somehow to groups in the same place. So this isn't too bad because there are few, and even if we go to the implementation, it's also not truly that bad because it's basically just create, read, update, and delete stuff. So pretty simple, just using Entity Framework. Because this was what the application did. So right now we want to evolve the application, and we will start to create more logic, more than just create, read, and all of that. So as you remember when we did this, or you might remember, if not, if you are new here, great, but okay. So we need to take into account the current user and stuff like that, and over here we weren't doing anything like that. We were just getting groups, putting them in there. So this would grow fast when we started adding logic in here. And that's one of the things I don't like. So we would be always touching this same class, touching stuff that doesn't really relate, even though it's about the groups, but it doesn't make everything need to be tied together. Another thing is that, let me go back here, we have some models here, or DTOs, call it what you want. Basically, we just have a group and we do everything with this one DTO. So if we go back to the interface, we use this DTO to everything. So to list the group, to get just one group, when we update, use the same group, and adding the same again, we always reuse the same DTO. And this brings some problems. If you remember, or for instance, we go to the controller and we, for the gets, no problem. But if you notice here in the update, we're doing these kinds of weird things because the client might send an ID that isn't the correct one, because as we accept a group model that has all the properties, the client can put everything in there. So in this case, we were overriding, and I was already anticipating the use of Mediator, but so I was getting the ID from the route and overriding what the client was sending. And for instance, in add a sync, because the client could send something, I was putting in a 0 just so it was clear that we are ignoring it. So this is another problem. The main problem for me is the big service class that does everything. A second problem, maybe not less important, but very common, to reuse the classes everywhere. So another thing we are going to take advantage with this refactoring is an add and an update are different operations that require different information. So we'll split it. Even the DTOs will be different. So those are the two main problems. Big classes with tons of logic and reusing DTOs everywhere. So how will we get rid of this? So imagine we are going to do it in a bit, but imagine we go to the business, and instead of having a service, a group service, we have something called I create group, or ignore the interface. We have something that is create group, which is the use case we want to do, or create or update group. Let me check here. For instance, here, let me collapse this part, which is for later, but check these use cases here. So we have a use case that is create group, another delete group, get user detail, get user groups, update details. So we have one thing for each use case, and this will be a different class to handle each case. Not only that, besides a class to handle each case, we will have a different DTO. So imagine here we have an update group details command, which is like the DTO for the update group details use case. Then we will have an handler. We'll see this in a bit, but the handler will be basically the service that the sole purpose is to handle the update group details use case. And finally, we'll have an update group details result, which will be the output DTO. So this will be the input DTO, and this one will be the output DTO. So we can tailor the information required as an input and that we provide as an output, specific for each use case, instead of reusing everything. And by using one handler for each, we don't mix all the code for all the types of use cases. But we'll get back here in a moment. So to implement this, we will use Mediator, which is a simple but useful package that allows us to create something that works basically using message passing in memory. So we'll use, in our case, we'll just stick for request response message in this case, but there's also the notification part. But imagine those DTOs that I showed, one input, one output. So these are like messages. We get a message as an input. The mediator will route that message to the specific handler, and then the handler will return the result, and it will be forwarded back to who called it. So we can take a look here at some examples. For the request response, ping is defining the request message, the input message, and it implements an interface, and the string will be the result of this operation. This iRequest is basically a marker interface to make it possible for Mediator to find where to route the message to. So afterwards, there's an handler, and the handler gets ping as an input and string as an output. And implementing this interface, we have the handle method where we get the input, the cancellation token for async stuff, as we talked in episode 10, I think. And then we can do logic. So imagine this as a single operation service. We could even call it a ping service or ping use case service, something like that. And we'll have just this. And then to use it, we just use the mediator and send the request. But we'll see the implementation in a bit. So let's go here. I have a bunch of them already created, but I left this to implement here for us to see how to implement this. So looking at how we implement, I had already implemented this. I have something that is a command, and if you are seeing by the names, this is a command, and if we open this get here, it's a query. So it's very following the ideas of CQRS, Common Query Responsibility Segregation, where we split the commands, the queries, and in this case everything it's segregated from each other, and that's why they have this name. A command is something that has side effects, and some say that it shouldn't return anything. I don't know. I think that's, if you're being purist, yeah, sure. But I think sometimes by following that rule to the letter, it's hard to, we get into more missing the word, more complexity, unneeded. Sometimes it's needed and you should go all in. Sometimes it's just unneeded, and we would end up doing async stuff with SignalR just to warn the client that something went well or not well. It seems overkill in some places. So this is an overkill series, but sometimes I simplify, at least sometimes. Okay, so we'll implement a create group, which is not a query, is a command. And so we'll have a command which will be the input DTO, the handler, and the output DTO, the result. So let's start. And I'll create a new class here, which will be, what's going on? Okay, create group command, and you have a new class, and we'll call it, I'll put sealed here because it's something I notice I forget a lot to put, but maybe we should. If the class is not supposed to be inherited from, maybe we should use the sealed keyword more often. And then we'll implement an interface which will be iRequest, and we haven't created the result yet, so object for now. And now let's create some properties. Which will be string user ID. I don't need a getter, or better yet, a setter. This is me being picky. I want this to be immutable. It's not needed. Mediator doesn't enforce anything like this. It's just my personal taste, and I would like to have this immutable. So we have the properties. So this is a create group command. So we need a name for the group, which we already had. And we want the user ID of the user that's creating it. So maybe the name should be creator user ID. But let's continue. C**p creates as a constructor with the properties initialized. And now let's create the result. Let's put here result. Add class result. And we'll take care of this in a minute. So this is the request, it's ready. So now let's create the handler. New class, handler. And another thing, just to get it out of the way, this whole way I'm organizing this, it's just because I feel like it. You don't need to separate things like this. If you want a much more pragmatic approach, check the Jimmy Bogart, which is the creator of Mediator and Automapper. And he has this project, which is Contoso University.NET Core, in which he used this. So then we have here in features, we can go, for instance, for courses, and he puts everything regarding courses in here. So it's the controller to forward stuff, but then he has a create.cs, and in here he has like a class create, the command, and the handler all together. So if you feel like you prefer this organization, it's much simpler, go for it. And he does it everywhere, then CS HTML. So if you prefer these kinds of organization, go for it. Makes total sense for me. Normally I like to split things a bit more, but I understand it's maybe too much a lot of the time. So if you want to simplify, take this approach. I'll leave this link as always in the blog post. So take a look if you prefer these kinds of organization. But let's keep going with our implementation. So our command handler. So we want an iRequest handler of create group command and create group command result. And then we can implement missing members. So like I mentioned, we want to create the group. So what we need to do, let me get back to the over here. So what we want to grab user by ID, set up group info, persist group, and return persisted group info. This is what we want to do. So some parts, most of the parts we will talk now, some bits will be for the next episode, but so we need a couple of dependencies here. We need a way to grab the user ID and a way to persist the group. To persist the group, over here in data, as I mentioned in the past episode, in data is where I put the interfaces for data access. I have an iRepository, which just has the the writing operations, which add, update, delete. So we will just use it to add a group. To get the user and stuff like that, we're going to use something I call the iQuery handler. We'll see in detail in the next episode, but this is basically the query object pattern. I think it's a pattern. So basically we'll have, as we are doing here for the commands, we'll have basically, imagine this as a repository for a single query, very specific query. Instead of having a repository, a generic repository, or having a repository with a bunch of methods, following the same idea as this use case segregation, this is basically query, database query segregation. But we won't go into detail about this today. It's for the next episode. So the only thing we need to know in this episode is we need the repository to persist and the repository to grab some information. So let me copy here an already prepared constructor and stuff. So this repository of group, what we will use to persist the group information, this iQuery handler, imagine this as the repository to grab user information by ID. And I'm putting things here, initializing stuff in the constructor. So now we can use it. So let's start by grabbing user by ID. The user will be await, it's sync. So await user by ID query handler, handle async, and we need a new which gets, this is basically the information that we need for the user by query, user by ID. So we need the ID. So we go to the command and grab the user ID. And in here we pass the cancellation token. So this is a pretty normal access to the repository to grab user information. Now we need to set up the group information that we got. Not a lot to do here. New group. This is also something that will change, but for now we'll do it old school with entities that just have getters and setters. So getters and setters and the information and the navigation properties. In the future we'll change that in a couple of episodes, I guess. But for now, what the group needs, the ID is not, so it needs the name, which is the request dot name, and needs the creator, which is the current user. Another thing we need is for the relations, let's go here. So we need to associate the user to a group by doing group user, and this group user, oh, I forgot to remove this part. Okay. And this group user associates things, and there's a role if the user is an admin or a participant. So we need to create this relation. This is one of the reasons we need to move from this way of doing things. So group users dot add new group user stuff. So group is group, user is user, and role is admin, as it's the user that's creating it. Okay, so we have the information needed. Now we just need to persist. Oh, let me put this here. Did I put it here? Yeah. Okay. Now persist. We have the repository. So we can do something like await repository dot add group. And the discussion about needing repositories or accessing entity framework and all of that, it's probably for the next episode, but as you might expect from me, I'm a bit of a meh. Do what do you prefer? So, okay. So just return persisted. So now is where we will put all the information here. To put information here, we can take a look. What is the information we want to expose? So at least the group name and ID we want to go return. We also probably want to return, let's take a look at the group, this row version. The name is terrible. I should change it in the future, but for now it's enough. We can return the row version to allow to check for concurrent updates. The creator, it's not really needed, but we can return it. The other users, for now, let's not put it. But so let's create this. So how will we create this? We could return the entities or something like that, but again, to use DTOs to keep things separated and return instead of always reusing stuff, create objects that are handmade for each case. We'll create a DTO. I'll copy things right now because it's not that useful. But let's take a look. Basically, putting the information, the ID, name, row version, creator, and notice that this user creator is a class internal. Is just an internal class to use just here. So, is it needed? Could we use the other one? Sure, but we would be passing everything in the user. That at this point is probably not a lot. Let's take a look. So not a lot, but for instance, the user groups would go, and that's really not needed. Or maybe in the future we'll have more information. And in this case, we probably just want the group user to go without other things. So imagine this as doing, in this case, not yet, but imagine this as putting the information that the UI needs. Instead of putting too much or too little and making the UI make too many extra requests, we tailor the response to the needs of the applications. And also, imagine that for the create group, we want a different set of information from the update group. This is a way to do it, and by touching one of them, we wouldn't break the other one. That's another important feature, I guess, from this segregation, is that as long as we are adding more features, we shouldn't break the other ones. If we just reuse classes and always touch the same places, it's much easier to break another thing without noticing it, because we are always touching shared stuff. In this case, by using these kinds of splitting the DTOs and splitting the code, the handler code, it's not impossible for us to break the update part, but it's harder because we centralize the create code here and we didn't touch anything for the other use cases. So let's return the information. So basically we return new result. So added group dot ID, added group dot name, edit group dot row version. Splitting this up a bit. New user, current user dot ID, current user dot name. What's going on here? Oh, okay, and that's it. This is the handler. Now you say this is pretty simple. Yes, for now it is. Hopefully we'll have more complex use cases in the future. And when we, in the next episode, we take a look at making things more object oriented. This will be even simpler because the group will have logic inside it. But for now, that's what we have. So, what are the advantages of doing this way? For starters, remember the superclass I was talking about. So imagine that this logic and the delete group logic and then the square logic and the other one and the other one. Imagine all this logic in the same class. So it's still not very complex logic, but it tends to complicate. So for starters, we have much smaller classes. Another thing, thinking about the solid principles that everyone loves and ask about in interviews and talk about in the interwebs, and then nobody does anything regarding that because it's single responsibility principle, the open close principle, and the interface segregation principle are all down the drain. For instance, let's go back to that code that I showed earlier. So the iGroup service does everything and there's all of this. So let's start for the single responsibility. So we think about single responsibility as having a single reason to change, but in here we have a bunch of reasons. So if we want to change the list and get by ID and update, different reasons. Is it that bad? Is it so serious? No, but people are always selling and we can do better in that regard. And related to this, the open closed principle, where we should be open for modification, open for extension, closed for modification. Again, we are modifying this all the time. And it's not easy to extend, to put more information, to put more features without having to touch. In something like this, we could use, for instance, a decorator pattern. And if we wanted to add caching to all the queries, we didn't need to go here and change this code. We could create a decorator for the handler, or in case of Mediator, we could do something that's called behaviors. Where is that? Go here. Behaviors. So for instance, logging, it's another example. Instead of putting logging inside the handler, we can put something that's a behavior. Think of this as a pipeline, and the behaviors are called before the handlers. So we could create a behavior for caching, a behavior for logging, a behavior for performance monitoring, stuff like that. We could also do this in here, create a decorator, but the decorator would need to implement all the methods, or we would need to use something like a Castle Dynamic Proxy to generate proxies with reflection and all that shenanigans. And it's much simpler if we have a single interface for handling, and we can plug and play stuff on top of it. So it's great for the open close principle because we're really open for extension and modification. Of course, sometimes we need to change things, but by splitting things up, we touch it less times. And for the interface segregation principle, yeah, this is not segregated because a dependency that's just needs to read. We'll also have a dependency on updating, adding, removing. So again, not very serious, because these aren't rules. These, at least for me, these aren't rules, are principles that we should try to do as best as we can. But sometimes it doesn't make sense. So we can do a bit better, and in some places we will get benefits from it. Where we don't get benefits, no need to do it. But when we do get those benefits, we can take advantage. And I guess this is one of such places where we simplify things. So now, to wrap this up, we have the use case, but how do we use this? So, of course, I forgot to show you that part, but this as a dependency on Mediator, because for us to get those interfaces. And then in the web application, we have not only that dependency. Let's see here. We have a dependency on Mediator extensions dependency injection. So this has extensions that make it really easy to add Mediator stuff to ASP.NET Core application using the built-in dependency injection. So where we use dependency injection in this application, we put stuff in the service collection and extensions, and to register things, it's already done, but let me show you. So we should go here, services, add Mediator is already here, and has a bunch of overloads. And the one I'm using, because it's pretty simple, is we can just tell Mediator the assembly which contains the request handlers in this case, and Mediator will scan that assembly and inject everything automatically into dependency injection. That's why we have this here. So I'm grabbing the, or in this case I'm getting the type for a query, and Mediator will scan the assembly for this type, finding all the handlers and requests and notifications and behaviors and stuff like that. So it's all over here. And then to use it, I reorganized this a bit, removed the controllers and moved to features, groups, and everything groups related will go here, a bit inspired by the way Jimmy Bogart organizes things, although I'm more complicated because I created other projects. He just puts everything in the same, much more pragmatic, I'd say. Okay, so over here we need a dependency on iMediator. So we inject the iMediator in the constructor, and then we can go to the create, the add async, which will call the create user create group. It will return create group command result. I could create another model or a DTO, but I don't feel it's necessary. If you want to change the information, sure, but I'm just passing the information back. The only difference, and I'm just doing this model because, for instance, in this case, the only thing that comes from here is the name for the group, because the user information is not sent by the client. The user information is part of the token that we got from identity server, so it's in there. So I have two models just because of that, because some parts I go grab in one place. And in the future, I also need to play a bit with model binding to see if I can do some magics. But regardless, for now, we just want to invoke Mediator. So what we do is result and await mediator dot send. Publish is used for the notifications, so we just publish and let it go. Send is for the request response type of thing we are doing now, and pass in the request, create group command, and the user ID is in, I can grab it from a service I have here. User ID and the string name, which is from the model name, and then the city is passed here. So let's just see over here how we did this. Web, this is the old way. Let's see, add async. And result.id, and we just pass the result. So this is working as it was before, but using the segregated handlers approach, and with that difference that instead of using a group model for everything, we have a create group command model. And if we go to the update, we have an update, and you see it's different in this case because the update needs the ID of what's updating, the name, that's the only thing that the user can update right now, but we'll change that, and the row version. But of course the create doesn't need any of this because, oh, not a result, sorry. The create just needs the user ID and the name, doesn't need the ID of the group or the row version, because it's creating, there is no row version. And that's it. Let me check the notes if I see something. Nope, doesn't seem so. Okay, I think that's it regarding this topic. Okay, so that's all for now. This is regarding let's just go here. Just regarding this segregation and using Mediator, it's pretty simple. And if you don't want to add a dependency on Mediator for some reason, it's easy to do yourself. For instance, create an interface called iRequest handler that gets an input and an output. Then you can use decorators to put things, so to decorate and extend those handlers without touching the code, and then inside the handlers just do that. And for instance, you can, let me show you here. Over here, where is that? Repositories, yeah, over here I did this something similar. So I did a simplified version without Mediator, and in the controller I would inject something like this, an iRequest handler, with a request and a result. In this case the result was was unit, which is basically void, but and injected it with this from services magic from ASP.NET Core instead. So if you don't want to use Mediator, or you create your own Mediator, or do something much simplified, which in this case is this, just a request handler, and then you can do some dependency injections, shenanigans, and it will work as well. So this is another approach. So you like Mediator or not, but the approach, for me, it's nice. Separate things. Instead of having superclasses, having simple classes, focused on doing one thing. And then if you want to create a lot of private methods with great names for your logic, it's easier to do this way, because if you had a giant service, you would mix a ton of private methods from a ton of use cases. In this case, you just have the private methods for that use case. I really like this approach, and I think that's it. In the next episode, we'll take a look, if I'm not mistaken, at the way I'm doing persistence here. It's not super interesting, but we'll just take a look. And for now, that's all. Hope you enjoyed it, and hope to see you in the next one. See yas!